In this video, we'll be taking a look at the Lesson 9 packet for our coding unit. So to begin, it says, in your video game at this point, nothing is happening when the player collides with the target, which is where you should get points, or when the player collides with the danger, which is where there should be a game over or lose points. What we're doing in this lesson is we need to know what collides means, and we need to know how far apart our characters are so that we know when the computer should detect these collisions. So your video game file provides a function called line length that computes the difference between 2 points on a number line. Here is the design recipe for line length that is already given in the code. So this image right here is actually a screenshot from some of the code that's already in your video game. So in our video game, we have already loaded in the code for update danger, update target, safe left, safe right, on screen, update player, which we just did in lesson 8, and now in lesson 9, this code right here, this line length code, already exists in your video game. So let's explore what this code is doing and why it's used. So the contract for this line length function says that the line length function takes in 2 numbers as inputs and produces 1 number as an output. The purpose statement: the line length function finds the distance between 2 points on a number line. The first example, line length 20, 10, so basically how far away is 20 from 10 on a number line? They're 10 apart, so it gives what the function should evaluate to there at the end of that example. Second example, line length 10, 20. So this time it's the same 2 inputs, but they're in the opposite order. The question is still, how far away is 10 from 20 on a number line? And of course, they're still 10 units apart. So we find that we get a positive 10 in both of those examples, even though the 2 inputs are in a different order. So when we take a look at our definition, define line length A, B. Specifically, I want to point out here that A is representing the first input and B is representing the second input. So we don't have to guess which one is A, which one is B. It depends on which one is first and which one is second. So what we find in our definition here is that the line length function actually uses a conditional with 2 clauses underneath. The clauses are the lines that begin and end with square brackets. So the first clause, which I will actually call clause 1 so that we can refer to it easily. Clause 1 says that if A is greater than B, then the computer is supposed to evaluate A minus B. So in other words, if the first number is greater than the second number, then subtract A minus B. So what we find in that case is if A is the larger number and B is the smaller number, that's the way that we're subtracting them. We're subtracting larger minus smaller. The second clause, which actually is an else clause, we will call it clause 2. The else clause actually incorporates every other option besides A is greater than B. So clause 2 is if A is less than B or A is equal to B, then what we're supposed to do here is subtract in the opposite order, B minus A. So the second input minus the first input. So then we would subtract B minus A. So in this case, if A is the smaller number and B is the larger number, we're subtracting larger minus smaller in clause 2 as well. So for each of the following, determine which clause applies and then evaluate the code based on what the clause indicates that you do. So our first example, line length 2, 5. Which clause applies? So first of all, we have to determine, is A greater than B? So is the first input greater than the second input? Or does it fall in the other clause, which incorporates everything else? Well, we find that clause 2 is the one that applies because in this case, A is less than B, which is exactly what we see up here for clause 2. So evaluate the code. Well, if we're using clause 2, we have to subtract B minus A in that order. So that would be second minus first, 5 minus 2, and we get an answer of 3. In letter B, we have to evaluate line length 5, 2. So this time we have the same 2 inputs, but they're in the opposite order. So this time the first input is greater than the second input. A is greater than B. So clause 1 applies. And what we're asked to do if clause 1 applies is subtract A minus B. The first input minus the second input 5 minus 2, which of course is still 3. So I'd like you to pause the video now and try C and D on your own. So letter C, A was greater than B, clause 1 applies. So we subtract first input minus second input, and of course we get 7. Letter D, keep in mind a negative number is always smaller than a positive number, so A is less than B. That means that clause 2 applies. So we have to subtract B minus A, so 2 minus negative 5. Keep in mind subtracting a negative is really the same as adding, so we're really doing 2 plus 5, which is 7. So what you probably noticed here is that all of these answers have been positive numbers. So number 4 asks us to explain why the evaluated code is always positive. So I'm going to go ahead and jot down an explanation and we'll read it. So the explanation I would come up with here for why the answer is always positive is the line length function always subtracts the larger number minus the smaller number, regardless of which input, A or B, is larger or smaller. So the two clauses determine in which order they get subtracted. We will always have a positive answer. Number 5, explain why line length needs to use conditionals. I'm going to write down an explanation, be back in a minute. My explanation here says that the conditional must be used because it must check to see which input, A or B, is larger, and then only evaluate the clause that ensures a positive answer. So we know that the way a conditional works is the two clauses basically ask a true or false question. So is A greater than B? If true, then evaluate A minus B. If false, then move on to the next clause. So what makes the conditional necessary is that only one of those clauses will be true, and that's the only one that will be evaluated. Of course, it will subtract larger minus smaller always. On the next page, let's take a look at number 6. In the example shown below, the smaller circle has a radius of 1, and the larger circle has a radius of 1.5. So we see two circles here, both on a number line. They give us the radii of the smaller circle and the larger circle. The circles will overlap or collide if the distance between their centers is less than the sum of their radii. So let's go ahead and figure out what this is saying. So letter A, the distance between their centers. The picture shows that the center of the smaller circle is at 1 and the center of the larger circle is at 4. So to find that distance, we are just going to subtract larger minus smaller. The centers are 3 units apart. The sum of the radii, sum means add, so we're going to take the radius of the smaller circle, which was 1, and the radius of the larger circle, which was 1.5, and add them, and we get 2.5. So letter C, is the distance between their centers, which was 3, less than the sum of their radii, which was 2.5. So is 3 less than 2.5? No, of course not. So the question is, will the circles overlap or collide? My explanation would be no, since 3 is not less than 2.5, then the circles will not overlap or collide, meaning the computer would not detect a collision between these two circles. Letter D, what if the two circles remain in the same locations, but the bigger circle's radius increases to 2.5? So we're going to go through the same method as A, B, and C and figure out what's changed. So the distance between their centers would still be 3 because it says they stay in the same locations, but the sum of the radii will have changed. The smaller circle still has a radius of 1, but it says the bigger circle's radius increases to 2.5. So now we're adding 1 plus 2.5, which is 3.5. So now, is the distance between their centers less than the sum of their radii? This time is 3 less than 3.5? Yes, so the circles this time will collide or overlap. So the computer would detect a collision since one of the characters or one of the circles is larger. All right, number 7. Unfortunately, line length can only calculate the distance between points in one dimension. That means it can only find how far apart two objects are directly left to right or directly up and down. So how would the distance be calculated between objects moving in 2 dimensions, like the characters in your game? Or, more simply, how about these two circles, the large blue circle and the smaller red circle? If I wanted to figure out how far apart are these characters or how far apart are these circles, how could I do it? I want you to think back to your time in geometry and and see if you can remember anything about how to find the distance between 2 points. I want you to pause the video now and brainstorm yourself, and when you restart the video, I will have come up with an explanation for you, and hopefully your brainstorming resulted in a similar idea. So here's hopefully something similar to what you came up with for finding the distance between these two circles. Let's create a right triangle whose hypotenuse is the distance between the circle's centers. Then use the Pythagorean theorem, which is a squared plus b squared equals c squared. So I already have my hypotenuse drawn and labeled with an x. That's the missing length. If I go straight vertically down from one of my points, I can actually count that it is 1, 2, 3, 4 units long. And if I go directly horizontal over to meet up with that other line segment, I can actually count how long that line segment is. And I actually have just created a right triangle, which I'll highlight in yellow so you can clearly see what I'm talking about. I've just created a right triangle whose legs are 3 and 4 units long and whose hypotenuse is unknown. So I can actually use a squared plus b squared equals c squared, where a and b are the two legs, so 3 and 4, and c is my hypotenuse, which I'll call x. I can very simply go through the algebra here and solve for x. At the end of the Pythagorean theorem here, we know we have to take the square root of both sides, and we get x equals 5. So that means that these two circles are 5 units apart. We can't actually count diagonally on a graph, but we can use the Pythagorean theorem to find that diagonal distance. Let's take a look at page 3. So the objects will overlap or collide if the hypotenuse, the distance between the centers of our two characters, is less than the sum of their radii. So in number 10 we come across the distance formula here, which hopefully you recognize from geometry. The distance formula will be the formula we will use to find the distance between the two coordinates, in general x1, y1 and x2, y2. Essentially we're computing the distance or length of the hypotenuse. So this is the distance formula here. It's the square root of x2 minus x1 squared plus y2 minus y1 squared, where x2 minus x1 represents how far apart the x values are, and y2 minus y1 represents how far apart the y values are. So we just discussed the function that finds how far apart the x or y values are. Remember, it was called line length. So we will use the function line length to find the distance between characters. For example, the distance between the points 0, 0 and 4, 3 is given by this formula here. I've given this to you. So instead of actually showing subtraction here, x2 minus x1 and y2 minus y1, I'm using the line length function with our two inputs, specifically our two x's, which I'll color code so you can see what I'm talking about, and then of course our two y's, which I'll color code so you can see what I'm talking about. So line length is finding the distance between the x's and squaring it. Line length is finding the distance between the two y's and squaring it. And then we're adding those line lengths together, and then we're taking the square root of the whole thing. So a couple abbreviations you need to be aware of is square root, which is SQRT, and squared, which is just SQR. So we're actually going to be writing the circle of evaluation for the distance function here. So the innermost circle is already done for us. Line length 4, 0 squared. We actually just need to repeat that over here for the other line length. So line length 3, 0 squared. And then the next function that takes place is the plus that's in the middle. And then the final function that takes place is the large square root symbol around the whole thing. So there's completed circle of evaluation for this distance formula, which remember was just an example to find the distance between two specific points, 0, 0 and 4, 3. We could substitute any other numbers for the inputs depending on where our characters are in our video game, anywhere on the screen. So at this point, the Lesson 9 Part 1 video is now over. To finish up this page and page 4, you'll need to take a look at the Lesson 9 Part 2 video.